We just looked at what a function is, kind of the definition of a function. And we saw a couple examples. We looked a little bit at domain and range for super strong Karen. And now we're looking at what's called a function map. So we have some data sets, some data points after one something for something. I don't know if it's time or what's going on here, but when 1 is put into this function, 4 comes out. When 3 gets put in, 8 comes out. When 4 gets put in, 2 comes out. When 7 gets put in, 9 comes out. So our input values are typically the x values, and the output values are typically the y values. So we got our input and our output, and there's something going on that's taking this input and creating this output. I don't know what it is, and that's okay. A function map, the way you draw a function map, you kind of saw this a minute ago before I put up the screen, looks like this. And the idea is that we have two oval shapes. The fact that it's a perfect oval doesn't mean anything. I got these ellipses, and it's just a way of kind of grouping. So the x values, the input values, that's the domain. So we're going to list all the domain values here, 1, 3, 4, 7. For the function map, it's proper to put the numbers in order from least to greatest. And so I put them in order from least to greatest. We also don't repeat any numbers when we're talking about a function map, and that'll make more of a difference here in a minute. So we've got 1, 3, 4, 7. And then the range, same idea. We're going to take all the range values and we're going to put them in this oval here. Again, in numerical order is the proper way to do it, 2, 4, 8, 9. And then to make a map, what we're looking at is we're drawing an arrow. Basically, we're saying 1 maps to 4. So whatever the function is, 1 goes to 4. Whatever the function is, 3 maps to 8. 4 maps to 2. There it goes. And 7 maps to 9. And that's what a function map looks like. If it asks you then to state the domain and range, the domain would be 1, 3, 4, and 7. It wouldn't be 1 through 7 because we don't know about 2, we don't know about 5, and we don't know if any of those work. So the domain is just 1, 3, 4, and 7. The range for this amount of information that we have here is just 2, 4, 8, and 9. And again, in numerical order, and that is necessary. When you're listing the domain and range, those do need to go in numerical order. For the mapping, it's proper to put them in numerical order, but for listing the domain and the range, that does need to be in numerical order. So the domain 1, 3, 4, 7, the range 2, 4, 8, 9. This is how the domain and the range map from one to the next, and this was our original data set. So that's what a function map looks like, and this is how we can write what the domain and the range are, basically the x values and the y values. So get another one. Now, as the title states, this is not a function. We're going to try and figure out why this is not a function. So we've got our x values, we've got our y values, we've got our inputs and our outputs. If I make my function map, if I make my ovals, I list all the input values. I've got 2, 3, 4, and 2. But 2, we're just going to write that one time. So I'm going to make my function map. I'm going to put 2, 3, and 4. My range values, my y values, I've got 6, 7, 8, and 9. So those are already in order, 6, 7, 8, 9. And I'm going to draw some arrows. I'm going to say, well, let's see, 2 maps to 6. So when 2 goes in, 6 comes out. 3 maps to 7. Go. 4 maps to 8. There we go. And now here's an odd one. 2 goes to 9. But we already know that 2 went to 6. So this is where we have a problem. This is why it's not a function. When 2 goes into this relationship, 6 comes out. 2 goes in, 6 comes out. However, when we put 2 in, 9 comes out. We don't know what's going to happen between those two. Going back to our problem. So yeah, 2 goes to 2 different spots, and that can't happen. We can't not know what's going to happen in our function if we put 2 into it. If we push a button and we don't know what the result is going to be, that's a bad button. And so this is not a function for that reason, that one domain value has 2 different range values that it maps to. And this is what our domain and range would look like. So if it asks you in an assignment or a quiz or a test to list the domain and range, you would only list the 2 once. You'd only list each number in the domain once because 2 can go in one time. and then you list the range, all the range values. One indicator that this is not a function is if there are more range values than domain values. That means that one of these has to go to two, at least one of these has to go to two different range values, and that's a problem. All right, graphs and deciding if it's a function. So there is a nice method for deciding if a graph is a function. It's called the vertical line test. And it tests the same thing as we were just doing. We were looking for one number that has one domain that has two different range values. But with a graph, the way we can do it is this. We can draw a vertical line. So if I have this graph, the V, the green V there is the graph. If I draw a vertical line, a straight up and down line, anywhere on this graph, it's only going to cross the graphed line one time, right here. So when 2 goes in, -2 comes out. So I again started at 0, 0, went over 1, 2. And so 2 was the x value, and I went down to -2. So when 2 goes in as the x value, -2 comes out, and that's it. There's no other value that comes out. If I drew the vertical line over here at x is -1, it would only cross the graphed line one time, right here at 0, 1, 0. So anywhere along this graph, if I draw a vertical line, I get one output. So this is a function. A circle. So we've got this circle shape. If I draw a vertical line through the circle, it crosses the graphed line, the circle, 2 times. We're not counting the x-axis because that's not the graphed line. It crosses the circle, though, twice. So if I put 1 into my relation, if I put 1 in as x, I get 2 different results. 1 goes in, and 1.9 maybe comes out. And down here at -3.9 comes out. And so I got 2 different results for the same x value. So domain has 2 different range values. That is not a function. Basically, when you draw that vertical line, if there exists a place on that graph where when you draw the vertical line, you get 2 different results, it is not a function. If you look at this one, this is more of an exponential function, which we'll talk about in chapter 6. If I draw a vertical line, it crosses at one time. This gets really steep here, but it doesn't ever get quite straight up and down. There is a start and a stop as well. And so with this one here, we have a stop point, or a start point. And so we would only be dealing with where that red graph is. We wouldn't go to infinity. So we wouldn't extend this out. It would stop here and here. We would just look at this section right there. So this does end up being a function. Last one I have here, this kind of cotangent almost shape. And so if we have this E-looking shape here, graph, if I draw a vertical line, this is not going to be a function because that vertical line crosses the E 4 different times. 1, 2, 3, 4 different times. And so this is not going to be a function. All right, so looking at all those different examples, the L is a function, the O is not a function, the V is a function, and the E is not a function because of that vertical line test. One other word that I've been using a little bit is the word relation. This will not show up on the test, but a relation is basically like the circle. You can graph a circle. There's an equation for a circle. It exists. It's a thing. It's just not a function. And so a relation is where there is a connection between domain and range. It's just not a special relationship like a function. And so the easiest way to think about it is functions are special types of relationships, or special types of relations. All functions are relations because it's one domain has exactly one range value. A relation just says there's a connection. So all of these are relations. There's a relation between a relationship between the x and the y. There is an equation for this circle. This E does have an equation. This is a relationship. It's just not a function. And so if you think about it with squares and rectangles, if you've heard this before, all squares are rectangles, but not all rectangles are squares. It's kind of the same thing, that all functions are relations, but not all relationships are these special things called functions. And that's what a relation is. So that won't show up in the test, but it does show up in the text, and so I wanted to comment on it.